We're going to start now with sector formulas. A sector is a portion of a circle. So for instance, this would be a sector. This is considered to be the radius here. This arc part here is considered the arc length, denoted by S, and the angle here is called the central angle, and we usually indicate it by theta. So for the formulas, to start with, let's do the formulas in radians. You have two different, ways you can write the formula. You can do it in radians or degrees. So let's start with radians. To start with, if you're going to have a formula in radians, think about, to start with, we'll be dealing with 2 pi would be an entire circle. So let's start with arc length. So if you were talking about the arc length, this part here, if you think about it, if it was an entire circle, it would be circumference. So it's going to be a portion of the circumference. So we would say the arc length is equal to theta, which is your angle, divided by 2 pi, times the formula for circumference, which is 2 pi r. But then you notice that this would be like 2 pi over 1. The 2 pi's would cancel, so you really get arc length is equal to theta times the radius. Alright, so if you're trying to find area, likewise, still in radians, area would be equal to theta over 2 pi. This is going to be your portion of the entire circle, and then you'd multiply it times the area of a circle, which would be pi r squared. Okay, if you look at that formula, it looks like if you put a 1 underneath here, you could cancel the pi's, and so it would actually be theta r squared divided by 2. And that is the formula for area if you are in radians. When we go to degrees, we'll develop them very, very similarly, except for instead of theta over 2 pi like we did when we were in radians, we're going to say theta over 360. So arc length is equal to theta over 360 times the formula for circumference, which is 2 pi r. If you'll notice, not as much cancels out as what it did when we were doing radians, but 2 over 360 does reduce, so it would be arc length is equal to, the 2 would cancel and this would become 180. So you could say it's going to be theta pi r divided by 180. So that would be the formula really for arc length. For area, you will say theta over 360, that's your portion of the circle, times the formula for area of a circle, which is pi r squared. And if you notice there, really nothing cancels, so it's just going to be, you just kind of like write it as one fraction. So it'd be theta pi r squared divided by 360. So those are your formulas for radians and for degrees, for arc length and for area.